Okay, 3, 2, 1, testing, testing, testing. Today, we're talking about graphing trig functions. Now, let's talk about our parent graphs. Alright, today we're going to start with two parent graphs. Alright, and the first one is y equals the sine of x. Now, this is a sine graph, so as always with sine, we're focused on our y values, Now, I'm going to draw a unit circle up here just because I'm going to reference it at multiple times throughout the video. Alright, so there's my unit circle, again, with this coordinate being 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, again, it's our unit circle with a radius of 1. Now, when graphing a sine curve, all right, here's my x and y axis. All right, and we're going to talk about three things today. First thing we're going to talk about is my period. Now, your period is going to be 2 pi. For today, our period is going to be 2 pi all the way through. Now, your interval, again, today is going to be pi over 2. All right, so, and our amplitude is going to be 1. Now, our amplitude is going to change as we move along. And I'll explain each one as we go. So, our amplitude is going to be 1. So, by period, I mean we're going to do one full period. Okay, at intervals of pi over 2. So, my first interval is going to be pi over 2. My second interval is going to be 1 pi, 3 pi over 2, I wrote 3 pi over 2, and 2 pi, which kind of makes sense, right? Those look familiar. Those are my values if I were to rotate in radians, and then we're going to go the other way in the opposite direction. Negative pi over 2, negative pi, negative 3 over 2 pi, and then negative 2 pi is back here. Alright, so those are my intervals, pi over 2, and one full period is 2. So let's say we wanted to graph the sine of x. Now, let's look at this. The sine of x. Sine is focused on our y values, remember. So what is my y value? Here, my y value is 0. So a sine graph starts at 0. Now, as you go pi over 2 radians, all right, as you go to the top, my sine value is now 1. So, let's call this 1 and this negative 1. All right, so as we go here, my sine value goes to 1. Now, as I go along this curve, my sine value goes back to 0, right, at 1 pi, right, because this is 0. Pi over 2 is up here. Okay. 1 pi, okay, 3 over 2 pi, and then a full rotation is 2 pi. So my sine value at 3/2 pi is negative 1. So now we drop down here, and then once we get back home at 2 pi, a full period or full rotation is back at 2 pi. All right, so what this curve actually represents is a full rotation around the unit circle. So your graph actually looks like that. Now let's go the negative direction. So let's say we're starting here. We're still focused on sine values. We start at 0. Going backwards, okay, this would be negative pi over 2, right? Because we're negative now. So instead of 90, now we're at negative 90. So this would go down 1. So we go along back to the middle, all right, up to 1, and then we close back at 0. So my curve would continue like that. So that's the sine curve, and that's where it comes from. All right, and if you notice, the highest sine gets on our unit circle is 1. The highest our graph gets is 1. The lowest is negative 1. All right, again, from 0 to 2 pi is one cycle. And from 0 to negative 2 pi is another cycle. One full cycle is a period. All right. and we have 4 tick marks. We had 4 checkpoints. Okay, so to find your period, you could always take it and divide it by 4, and that'll give you your check marks. All right, now let's do a cosine graph. Let's do a cosine graph. So now we're dealing with y equals cosine of x. All right, again, my period's going to be 2 pi. My interval is pi over 2, and my amplitude is 1. All right, so again, your period is 1 full cycle. Your interval is our tick marks, what we're going in between. And the amplitude is how high and low it goes. All right, the highest it got was 1, the lowest it got is -1. So that's why my amplitude is 1. So amplitude is high-low, interval is our tick marks in between where we're evaluating the graph at each point, and 1 full period is 1 full cycle. Okay, so let's look at cosine now. I'm going to draw, or we can reference that unit circle up above again. All right, or let's just draw another one to make our life easy. Draw another unit circle down here. And we have 1, 0, 0, 1, -1, 0, and 0, -1. All right, so here's this. My intervals are going to stay the same. Pi over 2, 1 pi, 3 pi over 2, and 2 pi. This is -pi over 2, -pi, -3 pi over 2, and -2 pi. All right, with my highest point being 1, my lowest point being -1. Now, let's take a look at cosine. Now, cosine, we're focused on my x values, right? When we're doing trig with our unit circle. Cosine, we're focused on my x values. So let's look at those there. So now cosine actually starts at 1. So a cosine graph starts at 1, where sine started at 0. Now as we work our way around, cosine at pi over 2 goes to 0. Then it goes to -1. Then it goes back to 0 and back to 1, 1 full rotation. So my cosine graph looks a little different, like that. All right, I probably could have spaced my interval out. Now let's go negative. So to here, I go to 0, to -1, back to 0, up to 1. All right, and that's 1 full period there. So it's all referencing our unit circle. I said this thing's all almighty and so important, and this is why. Because it brings us back to graphing, and it really connects those relationships between radians and the points and everything that we graph. All right, so let's kind of generalize some of our equations here. So we have y equals a times the sine, let's just use for this sake, of b times x minus c plus d. Now today we're focused on our a value and our d value. So your a value adjusts the amplitude. And remember, the amplitude is how high or how low your graph goes. Now what happens in between stays consistent with the graphs we just saw. And then our d value simply just moves the graph up or down. Okay, it's a vertical, it just shifts the graph up or down. So moves graph up and down. So let's try some variations of our parent functions and then go from there. All right, so we have example 1. Y equals 3 times the cosine of x. All right. Now, my period is 2 pi. My interval is pi over 2. So those are things that we've seen already. Now I'm going to change my amplitude to 3. All right, and watch how this changes everything. So here's my graph. Oh, that's not a very straight line. There's my graph. Okay, my intervals are the same. We got pi over 2, 1 pi, 3 over 2 pi, and 2 pi. Okay, and then I got negative 2 pi, negative pi, and negative pi over 2. I'm going to leave that one blank. We know what it is. I just don't want to squeeze it in there. All right, so now we have an amplitude of 3. So before our amplitude was 1. So now our graph's going to, our highest point is going to be 3, and my lowest point is going to be negative 3. All right. So for now, these axes are staying the same, our period and our interval. So now we said cosine. Okay, if you like to draw this little reference every time, I'm okay with that. It makes sense to me too. All right, because it reminds us that cosine, we're focused on our x values. So we start at 1, but in this case, now 1 is kind of like 3. All right, because my amplitude is 3. So basically, what we've done is we stretched this circle out, and we stretched our graph up. Our amplitude tells us how much we stretch it, how tall it is. All right, so it's the same thing. We start at 0. Okay. I'm sorry, we start at 1, but here we're starting at 3, right, because our amplitude stretched. We go to 0, down to negative 3, back to 0. We end up at 3. All right, then it'll go the opposite direction. We start at 3, we go down to 0, down to negative 3, back to 0, back up to 3. All right, I missed my dot, but you get the point. Now, so amplitude is how tall or how stretched. All right, and think about it, when you have sound, amplitude actually refers to sound, right? If this is like a sound wave, and you turn the amplitude all the way up on your amp when you're playing your guitar, it looks more like this. The waves are exactly the same, it's just the amplitude's a lot higher, a lot louder, so now it's stretched those waves to represent a louder sound. All right, so that's kind of the point of amplitude. All right, now let's do another one. And we're going to move a little quicker here, now we know what's up. So number 2 is y equals, let's go negative 2 times the sine of x. Negative 2 times the sine of x. Our period's still the same, 2 pi. My interval is pi over 2. This time my amplitude, I'm going to put it at 2. My amplitude's at 2. So here's my graph. 1, 2, 3, 4. That's 2 pi, 1, 2, 3, 4, negative 2 pi, pi over 2, pi, negative pi, 3 pi over 2, negative 3 pi over 2. All right, now my amplitude is 2, so it's going up to 2 and down to negative 2, my highest and lowest point and where it's getting stretched. Now remember, sine starts at 0. As it rotates down, it goes to negative 2, back to 0, back to 2, back to 0. Starts at 0, goes up to 2, back to 0, down to negative 2, back to 0. All right, good. Now, tomorrow in class, this is how I can know if you stuck around this long. Okay, I'm going to give you the graph y equals 3 times the sine of x plus 2. And we're going to focus on this 2. So when you see me in class Monday morning, I want you to come up to me, and when you see me, the first thing you say is, hey, Mr. P, what do 2 do? What do 2 do? And I'll explain to you what the 2 does. And we'll start there in class and do 2 examples before I let you go and start working. All right, what do 2 do? What do 2 do? Check you laters.